Every year, more than 800 million containers pass through the world's largest seaports. But what is truly astonishing is that behind this massive flow of cargo, there is sometimes only a single person sitting inside a glass cabin, suspended dozens of meters above the ground, controlling a steel machine weighing more than 30 tons against sea winds in enormous momentum. From the ground, the job can look almost simple. A crane lifts a container off a ship and lowers it onto a truck or train. But just one inaccurate movement can instantly throw the entire operation below into chaos. Meanwhile, at megaports in Los Angeles, Shanghai, and Singapore, giant machines as tall as buildings continue operating day and night to keep the flow of trade between continents from being interrupted. So what exactly is happening inside the world's largest container megaports? Let's explore it together with Mandarin Tech. Right on the west coast of the United States, the Port of Los Angeles operates as one of the largest cargo hubs on the planet. In July 2025 alone, the port handled more than 1 million TEU, the busiest month in its history. Over the entire year, the total volume surpassed around 10.2 million TEU. That means millions of steel containers weighing dozens of tons are constantly being lifted off floating city-sized ships and moved across America's logistics network. From a distance, the STS cranes here look like gigantic steel skeletons lined up along the harbor. Some of these machines are as tall as high-rise buildings, with enough outreach to span the full width of the world's largest container ships. Beneath them are endless rows of 20-foot and 40-foot steel containers, stacked like walls with no visible end. But behind this landscape of steel and machinery lies a system that connects almost everything in the modern world. From smartphones, automotive parts, and imported food to even military logistics equipment, all of them must pass through ports like this before continuing their journey. To begin a shift, the operator must climb into a control cabin suspended dozens of meters above the port. The higher they go, the quieter the diesel engines below become, replaced by the sound of sea wind hitting the glass and the constant static coming through the radio. Beneath them, rows of containers continue moving between giant steel cranes stretching along the harbor. From a distance, the job can look slow and almost simple, but inside the control cabin, everything feels completely different. The operator is not just controlling a crane, they are controlling the entire suspended load hanging beneath it. At this height, a container no longer feels like ordinary cargo. It feels more like a giant steel block floating in midair. Every movement must be adjusted constantly. The operator has to watch blind spots below, read the sway of the load, and control gaps of only a few centimeters between the container and the cargo ship or truck waiting underneath. A mistimed acceleration or a turn that is too fast can instantly destabilize the entire load below. What makes the job even more stressful is that most decisions must be made almost immediately. While the distant city has already gone to sleep, the glass cabins above the seaport remain lit throughout the night. Between the radio chatter, sea wind, and the endless sound of machinery, operators must keep the flow of containers moving in perfect rhythm without allowing mistakes to happen. Everything usually remains under control until the container starts swinging in midair. A fully loaded container can weigh more than 60,000 pounds, equivalent to around 27 to 32 tons. But at container ports, the greatest danger is sometimes not the weight itself. It is the moment when the entire suspended load begins oscillating after a poorly timed acceleration or change of direction. In 2022, at the port of Aqaba in Jordan, a container carrying around 25 tons of chlorine gas fell from a crane while being loaded onto a ship. Just seconds after impact, a yellow toxic cloud began spreading across the entire port area. The accident killed at least 13 people and injured more than 265 others. That is why crane operators constantly monitor every small movement of the load hanging beneath the spreader. From inside the cabin, the container no longer moves in a straight line. It begins drifting sideways above workers, trucks, and cargo rows below like a gigantic pendulum. And once dozens of tons of steel become unstable at a height of several dozen meters, it is almost impossible to stop the motion immediately through control force alone. The inertia continues pushing the entire load forward even after the crane has already slowed down. In many situations, the operator will hold the container still for several seconds just to observe the sway before making the next movement. Every small adjustment of the control lever is used to cancel out the oscillation rather than create additional force. Beneath the crane, the spreader begins lowering so slowly that the movement is almost impossible to notice with the naked eye. And sometimes the hardest part is not lifting the container off the ship, but positioning the system precisely above it. Modern STS cranes do not use one giant hook like many people imagine. Instead, the entire load is connected through a rectangular steel frame called a spreader, the component that directly locks onto the container during loading and unloading. Inside the control cabin, the operator constantly adjusts the position using cameras, sensors, and gaps of only a few centimeters between the four locking corners and the top of the container. At that moment, the entire suspended load is actually being held by just four small locking points at the corners of the container. Yet this seemingly simple mechanism completely changed the global logistics industry. Before containerization, international cargo had to be unloaded manually piece by piece at seaports. A single ship could spend days unloading cargo. But once standardized steel containers became widely used in the second half of the 20th century, the entire transportation system was almost rewritten from the ground up. The same steel box can now leave a factory in Asia, cross the ocean aboard a container ship, then continue by truck or train for thousands of kilometers without being opened once. Above the spreader, the hoist system lifts the load off the deck while the trolley moves along the crane's giant steel boom, carrying the container from sea to land. But before the container is actually lifted away from the ship, there is still a moment when the operator must be extremely careful. After the spreader locks onto the four corners of the container, the entire load is still tightly packed among dozens of other containers inside the stack. Sometimes the gap between them is only a few centimeters. That means the operator cannot simply pull the load straight upward like many people imagine. They must lift the container out of the stack centimeter by centimeter to ensure the entire load rises evenly without hitting the surrounding containers. If even one corner becomes misaligned or the locking system is not fully synchronized, the entire operation has to stop immediately. Port accidents can sometimes begin from very small misalignments like these. Inside the control cabin, the operator is almost never allowed to guess. They must constantly monitor cameras, load sensors, and the behavior of the container during the first few seconds after it leaves the stack. Only once the entire load becomes completely stable do the hoist and trolley systems begin accelerating to move the container away from the ship's deck. Once the container clears the ship's deck and starts moving through the air, the operator usually stops looking at the crane itself. Instead, they watch the sway of the load. For new operators, the first instinct is often to pull the container back into a stable position as quickly as possible. But at container ports, that usually makes things worse. Panic creates more movement. Experienced operators move the controls very gently, sometimes so slightly that it is almost impossible to notice with the naked eye. They do not try to force the container to stop. Instead, they wait for the right rhythm of the swing and create counter movements to cancel out the force traveling through the cables below. Dozens of meters above the harbor, the container now behaves more like a giant steel sail than ordinary cargo. And if a crosswind hits at the wrong moment, the entire load can drift away from its original stable path. What makes it frightening is that operators often feel the problem before they even see it. A slight vibration travels back through the cables. The movement starts lagging slightly. The container reacts differently when the trolley changes direction. And suddenly the radio inside the cabin becomes quieter than usual. Down on the ground, workers, truck drivers, and the entire support crew are all watching the same suspended load moving above their heads. At many modern container ports, OSHA high-wind operating procedures are posted directly inside the control cabin. For certain lifting operations, cargo handling may stop completely once wind speeds exceed around 35 miles per hour. Because beyond a certain point, skill alone is no longer enough. From inside the control cabin, the operator cannot actually see the entire area beneath the crane. Stacked rows of containers, the massive body of the ship, and the distance of dozens of meters between the cabin and the ground create many blind spots throughout the loading and unloading process. That means there are moments when the operator is moving dozens of tons of steel without being able to directly see exactly what is positioned beneath the suspended load. Throughout the shift, the operator constantly receives information from spotters on the ship deck, ground workers, truck drivers, and the coordination team below the harbor. The commands transmitted through the radio are usually extremely short and leave almost no room for misunderstanding. Hold! Lower! Stop! Down below, workers must continuously stay clear of the load's movement zone, while truck drivers wait for the container to be lowered precisely onto the 4 locking points of the chassis. If even one person stands in the wrong place or reacts a few seconds too slowly, the entire operation above may have to stop immediately. In many situations, the operator even has to rely completely on guidance from the ground crew to align the clearance between the container and the truck or the adjacent stack. At that point, the radio becomes almost like a nervous system connecting the entire port through every movement of the suspended load above dozens of people's heads. After leaving the crane, the container still has not truly completed its journey. One of the most difficult operations begins when the load is lowered back into the container ship. From the control cabin above, the ship's open deck looks like a giant steel trench extending deep into the vessel below. Inside it is the vertical guide system, steel rails running through multiple container levels to keep the load aligned during the ocean voyage. At this point, a 40-foot container must fit precisely into a space only slightly larger than itself. From dozens of meters above the deck, the operator is essentially guiding a load weighing tens of tons through a narrow steel rail system deep inside the ship. Even a small misalignment while entering the guide rails can cause the container to hit the cargo hold walls or become stuck between the rails below. What makes the operation even harder is that the operator often cannot fully see the final placement point with the naked eye. They must rely on cameras, load plans, and instructions from the ground crew to determine exactly which bay inside the ship the container must go into. If the load is placed incorrectly, the problem no longer affects just that single container. It becomes a real structural force acting on the entire ship throughout its ocean voyage. A modern container ship today can carry more than 20,000 TEU in a single voyage. Inside those steel boxes may be electronic components for assembly factories, automotive parts for production lines, medical equipment for hospitals, or even cargo supporting military logistics. That is also what makes seaports one of the most important connection points in the modern world, where ocean shipping, rail transport, trucking, and national logistics networks all meet in the same place. If a ship arrives late at port, the effects behind it usually spread very quickly. Ships waiting offshore must continue waiting for their turn to dock. Trucks begin piling up around container pickup areas, while freight trains have to adjust transport schedules to free up yard operations inside the port. If container volume exceeds handling capacity even for a short period, the entire harbor can quickly turn into a steel maze, stretching for kilometers. During the global supply chain crisis in 2021, dozens of container ships were forced to anchor offshore near Los Angeles and Long Beach, just waiting for an available berth. From the air, the ocean in front of the ports looked almost like a giant parking lot filled with floating cities trapped at sea. That is also why many countries view seaports as part of their strategic power. Today, many container terminals have started using cameras, sensors, and remotely operated cranes to increase cargo handling speed. But at the final moment, there still has to be a human deciding whether the operation is safe enough to perform. When a shift ends, the operator does not simply climb down from the control cabin and leave. Before the next shift begins, the entire condition of the crane still has to be carefully checked again. At seaports, dangerous failures usually do not appear suddenly. They often begin with very small warning signs that only experienced operators can recognize. A load reacting slightly slower than normal when the trolley changes direction, a spreader vibrating differently while lifting a heavy container, or a braking system taking one extra moment before stopping completely. After years of working among thousands of moving containers every day, many operators begin memorizing the crane's movements almost by instinct. They know which loads are reacting abnormally, which areas contain dangerous blind spots, and when it is safer to stop the entire operation instead of continuing a lift that is no longer stable. Every day, millions of containers silently move between continents like the bloodstream of the global economy. Inside those steel boxes may be smartphones, car parts, food, or medical equipment used by millions of people. But behind that seemingly simple movement are control cabins suspended high above the harbor, loads weighing dozens of tons, and people who must make precise decisions almost every second to keep the entire system from stopping. The modern world may run on automation technology and giant machines, but at the final moment, there still always needs to be a human calm enough to keep everything operating safely between sea winds, inertia, and the pressure of a modern container port. If you enjoy technical stories like this, follow Mandarin Tech.